Yeah, thanks a lot, everyone, for the introduction. I'm going to have the video at the beginning of the talk, but then I'm going to turn it off because I'm a little bit scared that the connection might not be that great. But I just want to introduce myself at the beginning, and then we'll just dive into slides and demos throughout the talk. So as Ron said, I'm based in London, although I'm not originally from London. I've been in London for, I think, 7 years, more than 7 years now. But before that, I was actually living in the US. I was in Pennsylvania, in Gettysburg for undergrad. I went to the US to study, and then I went to Boston for grad school, and I was in Boston for a long time. So I think I spent more than 10 years, 11 years, something like that in the US. But at some point, I decided to come back to Europe, and I'm here in London now. And I'm originally from this a small island in Eastern Mediterranean called Cyprus, which is a really nice place to visit in the summer. So once we are back to normal, hopefully not too late, if you're looking for a nice place to visit, keep that in mind. So yeah, I'm a developer advocate at Google. I'm based in London. And I'm going to be talking more about Cloud Run and more about Knative, which is the underlying open source project that Cloud Run is based on. Martin did a really great job on explaining what serverless is and what Cloud Functions and Cloud Run is at the high level. But now I want to get into details of the underlying technology, Knative, and give you demos and more details on that. So I'm going to be spending quite a bit of time on Knative itself. And then we're going to switch gears and look at Cloud Run briefly, and then compare and contrast them. And then in the end, hopefully we'll have some time for question and answer. Now, the slides, they're already on speaker deck. So if you want them, you can get them from there. And everything I'm going to show, it's already on GitHub, the demos. So I'm going to share the links of those demos as well at the end of the presentation. So I'm just going to stop the video now, my video, because I can already hear my computer working overtime. So let me just do that. Okay. All right. So serverless containers with Knative and Cloud Run. We already talked about serverless, but let's just recap a little bit. So when we think about serverless, of course, there's a lot of different definitions of what serverless is and what people mean by serverless. But fundamentally, I think there's two different ways of thinking serverless. You can think of it as in terms of operations. So how do you actually run the code? And what does it mean to run that code in a serverless way? So when you run code in a serverless way, you mean that you don't need to worry about infrastructure. Of course, there's infrastructure where your code runs, but it becomes someone else's problem, and you don't have to worry about that anymore, which is a great thing to have. Or you might be thinking about managed security. Of course, we need to think about security no matter where you run or how you run your code. But the base level security is usually taken care by the serverless framework. So you don't have to worry about securing the machine or closing the ports, the low level details like that. Of course, you need to worry about authentication and authorization, and you need to make sure that your services are exposed at the right levels. But those are more higher level security things that you need to worry about. And then also, when you think about serverless, you usually think about paying as you use, right? Normally, when you have a physical machine or when you have a virtual machine, you pay no matter what. So even if no one uses your application, you still pay. Whereas in serverless, you kind of expect that you don't pay when no one uses, but you pay when there's a demand. At the same time, there's also a programming model way of thinking serverless. So when you're thinking about serverless applications, they're usually service-based. So we're creating services that are event-driven. So something triggers these services. It's either a pop-up message, or it can be an HTTP call. So something triggers and wakes up your service. And usually these services are stateless. Of course, every application has some kind of state, but the state of the services, they're usually externalized to something else, right? And the reason for this is that services in serverless world, they scale up and down, and it's much easier to scale services when they're stateless, right? So that's what we mean by serverless in general terms. But at the same time, we have these things called containers. Containers, the way I think about them is that it's a context that you can replicate anywhere. So you take your application and then you define its dependencies for whatever your application needs, and you put into this lightweight container. And then once you create this container, the way that runs on your machine and then the way it runs in the cloud is exactly the same. And that's the greatest thing about containers, is that it gives you this sealed context that you can replicate everywhere. And also the other thing about containers is that it gives you a lot of flexibility. You can use any language you want, you can use any library you want, and there's this great ecosystem around containers. So there are projects like Kubernetes, Istio, Knative that I'm going to talk about that make it much easier to run containers at a scale. So far, when you had to think about containers and when you had to think about serverless, you had to make a choice right at the beginning of your application development. You either went with serverless, which is great because it gives you all these building blocks, and that means that you don't have to worry about low-level details, and because of that, you can iterate fast and move much faster, so it gives you a lot of velocity. But then you lose the flexibility of containers, because when you are in a serverless environment, you're usually limited by what the cloud provider provides to you, right? So for example, on Google Cloud, if you want to use cloud functions only support Node.js, Go, Java, and Python, right? So if you are a C# developer like me, there's no support for C# yet. So if you need to use C#, then at that point, you need to look at something else. And that something else is usual containers. But then so you get the flexibility of the containers, but then you lose all these good things about serverless. So there was this choice that you had to make. Well, thankfully, you don't have to make that choice anymore. So projects like Knative and their managed versions, Cloud Run, they bring serverless to containers. So the way you can think about this is that you can run containers, but you can also get the benefits of serverless using these projects. So Knative, it's an open source project, and it runs everywhere Kubernetes runs, and it's the building block, it's the open source underlying technology that everything is based on, and that's what I'm going to talk about mostly. And Knative, as I mentioned, it runs anywhere you have Kubernetes. So if you are running Kubernetes locally on-prem, you can install Knative and it will work. If you're in Google Cloud, you can also run Knative yourself if you want. But there's also the managed versions of Knative called Cloud Run and Cloud Run on Anthos. So if you're already in Google Cloud, you probably don't want to set up Knative yourself. You probably want to use the managed version because Cloud Run makes it really, really easy to run Knative services in a managed way. So the Cloud Run is the managed version of that. So it runs on Google's infrastructure and is fully managed. And then there's another version called Cloud Run on Anthos, which is a version of Cloud Run that runs on Google Kubernetes engine. So if you want to stay in Kubernetes ecosystem, but you still want to use the managed features of Cloud Run, you can use Cloud Run on Anthos. Now let's first talk about Knative. So Knative, as I mentioned, it's a Kubernetes-based open source building blocks for serverless. So you can think of it as components that you install on top of Kubernetes so that you can turn Kubernetes into a serverless platform. Because if you ever use Kubernetes, you know that it's not a serverless platform at all. Because in Kubernetes, you have nodes, so you have actual virtual machines, and then you need to, if you want to expose a container onto these nodes, you need to create pods, and then you need to schedule these pods, then you need to create Kubernetes services, then you need to use, if you're using Istio for traffic management, you need to configure Istio the right way. So there's a lot of things that you need to do and set up front. So it's not serverless at all in that sense. But Knative tries to kind of turn Kubernetes into a serverless framework by giving you the building blocks so you don't have to do all of this yourself. And I'm going to show you what we mean by this throughout the presentation with demos. It's an open source project on GitHub. It was started by Google, but now a number of companies like VMware, Red Hat, and others, they're contributing as well. You can also contribute. It's written in Go, so if you know Go and if you're interested, feel free to check it out. The Knative stack looks like this. Now at the bottom layer, we have Kubernetes. Everything runs on Kubernetes. Then you need to install a gateway on top of Kubernetes, because Knative, it doesn't try to solve networking problems. It doesn't try to figure out how to get traffic to your containers. Instead, it relies on a gateway like Istio or Glue or Ambassador to figure out the traffic, how to manage traffic in your cluster. Usually people use Istio because it's the most full gateway that you can install on top of Kubernetes, and it works pretty well with Kubernetes. But some people prefer other gateways like Glue because it's more lightweight. So it's up to you which one you want to use. But either way, you install Kubernetes, then you install the gateway on top of that. Then you can install the Knative components. There's two main parts of Knative. One is Knative Serving, and the other is Knative Eventing. You can install them together, or you can install them one by one, or you can just use one or the other. It's all up to you. There used to be a third component of Knative called Knative Build, but that became a separate project called Tekton Pipelines, and I'm going to talk about that briefly at the end of the presentation if we have time. But if you heard of Knative Build, it's basically a project that kind of graduated into its own space, and now it's a separate project called Tekton Pipelines that you can still install in your Kubernetes cluster and use as well. So that's Knative, and everywhere you have Kubernetes, it works. But as I mentioned, there are products that are being built on top of Knative, such as Cloud Run or Cloud Run on Anthos. So if you're in Google Cloud, you should definitely check those out. If you're in other clouds as well, there's other products from other cloud providers that are being built on top of Knative as well. I didn't list them here because I didn't check them out myself. But if you're interested, you can find the information yourself and see. So if you're in any cloud, you definitely want to check what is the Knative implementation on this cloud. All right, so let's first talk about Knative Serving. So Knative Serving, in a nutshell, it gives you the ability to deploy containers in a serverless way. And what I mean by deploying containers in a serverless way is that, you just tell Knative, this is my service, and this is my container, sorry, and I want to deploy this container into this namespace, and then that's it. You just basically specify, this is my service name, this is my container, and Knative takes care of the rest. So it deploys a container in a Kubernetes pod. It configures traffic to that pod, so the traffic is going to that pod. Then it sets up automatic scaling, so that pod scales to 0 if no one uses it, and it scales up to n if more people use it. Then you get configuration and revision management. So every time you change anything about the configuration of your service, you can deploy again, and then you get a new revision. And with multiple revisions, you can do things like traffic splitting. So this is it basically in a nutshell. So it gives you the ability to deploy the container, get the traffic routed to that container, get automatic scaling, get the configuration and revision management, and also have traffic splitting if you need it. Now, the Knative Serving components are basically, there's 4 main components in Knative Serving. At the top level, you have a service. This is a Knative service. And people sometimes get confused because in Kubernetes, there's also the notion of Kubernetes service. Knative service, it's something higher level. It's not a Kubernetes service, it's a Knative service. And I'm going to show you an example of this shortly. So this Knative service has a configuration. In the configuration, you have things like the container of the service, and also things like the environment variable for the service. Then when you deploy the service with the current configuration, it creates a revision. And then it also creates a route that points to that revision. So all the traffic by default goes to that revision. Now, every time you change anything about this configuration, a new revision gets created by Knative automatically, and then route gets updated to that revision. So you get automatic updates to the newest revision. Of course, once you have multiple revisions, you can do more complicated things here. You can change the route and do A/B testing, or you can gradually ramp up traffic, things like that. So these are the main building blocks for Knative Serving. And let me show you an example of this actually. So if you, and I'm going to share this link at the end of the presentation. If you go to GitHub, on my GitHub, there's a Knative tutorial that I built. And in this tutorial, I show you how to set up Knative on Google Cloud. I show you manually have to set it up because I want you to understand what's involved in setting it up. But you don't actually have to do this manually if you use Cloud Run. And then I show some examples of Knative Serving and Knative Eventing. I want to take a look at just a hello world example now, just so that we know what's involved in setting up Knative. Now in here, what I want to do is that, I have a very simple container, and this container, when it receives a request, it will just reply back with hello world and with a revision number. The code is in C# and Python. I won't show you the code because it's not interesting. It basically just, when it gets a request, it will just say hello, hello, and then it will just output the version number that we're going to define. But you can take a look at it if you want. So the first thing that you need to do is you need to build the container. So we use docker build to build it. I give this version, I give this a version 1. And then I define a service YAML. In the service YAML, let me just quickly show the service YAML. This defines the Knative service. And let me make this a little bit bigger. So in this service, first of all, we are using the Knative API. So this is a Knative service. And then the name is a hello world. It will be deployed in the default namespace. And then this is a configuration of my service. In this configuration, I'm saying that I'm deploying this image. So this is the image that I pushed. And then I'm also passing in a variable called target, an environment variable. And I say the value is v1. So this is the variable that I'm going to read in my code, and then I'm going to print it out. So you can see that this is a very simple service definition, just pointing to my container and the environment variable. Now, to deploy this container, we will basically just say kubectl apply, and then we were going to watch some Knative events. So let's actually do this. So let me make sure that I'm in the correct place. So I have my service definition. So first, let's just watch some Knative things. So I'm watching Kubernetes pod, Knative service, Knative configuration, Knative revision, and Knative route. So all the things that I talked about Knative eventing, I'm going to watch. Now you want to see that, let's see if it works first. Yes, you're going to see that there's some pods running. These are pods that I need for Knative eventing. So we can just ignore them for now. Normally, you don't have any pods running initially, but I set them up because I'm going to show you some Knative eventing. Now let's deploy the first service. So what I'm going to do is I'm going to say kubectl apply, and then service v1, so the first version of my service. Now this says the service is created, and then you can see here that Knative immediately recognized that we applied a new service, and it created a new service for me. Then it created a configuration for the service. It created a revision of my service, and this is first revision, generation 1. And then it also created a route that points to the URL of my service. And this URL, as you can see, it has a dummy zip.io domain. This is a default domain that you can set up in Knative for testing. So that's set up as well. And then we also have a pod running. So our service pod is already running. So if I do a curl now, you can see that our service says hello v1. So it's up and running, right? So if you ever done any kind of Kubernetes deployment, you know that this is much easier because we literally just specify a YAML, and then we just said, okay, deploy this container, and then boom, it's done. We don't have to worry about the pods, deployments, Istio, gateways, virtual services, things like that. Everything is set up for me, which is great. Now, as I mentioned, every time we change configuration, Knative recognizes that and applies some changes, right? So every time we change anything in the configuration, we get a new revision. So for example, if we go to our service, and in this service, let's just say you want to change the configuration. So what I'm doing here is that I'm going to change the environment variable from v1 to v2. So that's a configuration change. We can do that and then see what happens. And then we can also change the code. So if I go to my code and then change my code to say bye instead of hello, I can do that. I can push a new image to the Docker Hub. Then I can come to my service, and then I can just update my service and go to image and change the image. So I'm doing two different changes here. One is the configuration change, another one is the code change via the image, right? So let's do those changes and see how those work. So first, let's do the configuration change. So again, kubectl apply, but let's say service v2. Now this will you can see that this immediately created a second revision, and then it also will create a new pod for it, and this pod is just created. And one thing that you're going to realize is that the pod of the first version is already gone. And the reason for that is that Knative has auto-scaling set up already. So because we haven't used the pod for 60 seconds, it scales down to 0, right? So it already scaled down, but the second version is up and running. And if I do a curl again, you will see that we are saying hello v2, right? So we are seeing the new configuration. Now, if I want to do a code change, I can say kubectl apply, and then this time let's do service v3. So this will use a new container that we just pushed. And now you will see that we have a third revision, and the pod is also running for this third revision. And then if you do a curl again, now we say by v3. So we did a code update. So you can see that the updates become really easy in Knative. Now, of course, in Knative, in developing software, you don't just update code just like this. You don't just go from one version to another version like 100% like that. What you need to do is that usually you need to deploy your code in a silent way and make sure that the code works. So you need to run some tests against that. And then once you're confident that the code is working, you probably want to send traffic to it gradually and ramp up traffic to that version. And then once you're really confident that the new code is running, you want to send all of the traffic to it, right? So you want to gradually ramp up traffic to this new version. So Knative makes this really easy. So first thing that you can do in Knative is that, so let's go back here. Let me close these. So we can do things like traffic splitting. So the first thing that you can do in Knative is that you can give your revisions. So our revisions right now, if you look at our revision names, they're random names, right? The revision names are random. Even though the generation is 1, 2, 3, the names are random. But you can actually give them predictable revision names. And by giving revisions predictable names, you can refer to them later. So that's why we want to give them good names. So here, if you go to your service definition, under the definition of the service, you can say metadata name and give your revision a name. So in this case, I'm naming this hello world-v1. This will be the name of the revision. And you can also set traffic rules. So here I'm adding a traffic rule, and I'm saying that I want the v1, the version 1 of my service, to get 100% of the traffic, and I want everything else. So everything else I deploy after that, I want it to not get any traffic, right? So let's do this and see what happens. So service v1 pinned. Now you will see that this created a new revision, and this revision has a predictable name, hello world-v1, right? And then this is also creating a new container for the new revision. And once the container is running, if you do a curl, we are back to version 1. So everything is back to version 1, but the difference is that the revision name has a predictable name. Now let's deploy another version, and this time this is version 4. Now the version 4 also has a predictable name, so you can see that the version 4 is also predictable. But the difference is that we haven't changed the definition of our traffic, right? So what we did is that we deployed the version 4, but then we didn't change the traffic. So the version 1 is still getting all the traffic, but version 4 is deployed. So I did a silent deploy here. And I can actually show you that. So if I go back to curl and do a curl, we are still saying hello v1. So we are still hitting the version 1. But then if I go back to my URL and add latest dash at the beginning, now we are seeing hello v4. So we did a silent deploy of version 4, and we have a URL that we can hit and test and make sure that version 4 works. And if everything is good, we can change traffic rules and we can send more traffic to version 4. Now to send more traffic to version 4, what we need to do is we just go to traffic rules and then say, okay, in this case, what I'm going to do is that I want version 1 to get 50% of the traffic. I want version 4 to get the other 50%. And then if I deploy anything else after this, I don't want it to get any traffic, right? So that's what I'm doing here. So let's apply this 50% traffic rule. service v1, v4 split. And now you will see that nothing changes here. We still have the same revisions, the same service and everything. The only thing that changes is the route. Now the route points to version 1 and version 4, 50%, 50%. And if I go back to curl and just do curl to the main URL, we see version 4. If I do another curl, now it says version 4, but eventually now it's hitting version 1, and version 1 scaled down, it's scaled up now, and it's version 1, version 1. So roughly 50% of the time it will be version 1, the other 50% it will be version 4. And then once we are done, let's say we are done with the service, I can just say kubectl delete knative service all, and this will delete all my knative services, and then all the processes will be terminated, and we will be back to, and these will be terminated as well, and we're back to normal. So this is Knative Serving in a nutshell. Let me go to my slides. Yeah, next I want to talk about Knative Eventing, the second part of Knative. And Knative Eventing, what it tries to do is that it tries to connect different kinds of event sources to different kinds of event consumers using a flow in the middle that you can define. And I know this definition is very generic, and it's on purpose because Knative Eventing tries to be really generic. I mean, it gives you a lot of different event sources that you can pull a lot of different events, and then it gives you different ways of connecting them to different kinds of event sources like Knative services and Kubernetes services. And because of its flexibility, it really can connect a lot of different things together. Now, in terms of how it connects things, there's a few different ways of connect delivery models that it can do. The simple, complex, and broker and trigger delivery. Usually, broker and trigger is the only one that you should care about. The rest of them, you might need them once in a while, but usually whatever you need to do, you can do it with broker and trigger delivery. But I will talk about the simple and complex as well, just so that we know how it works. So in simple delivery, you basically have an event source and you have a service. This is a Knative service or a Kubernetes service, and you want to directly connect them, right? You want to connect them directly. That's when you use simple delivery. The good thing about this is that it's very simple to define and apply. But the bad thing is that if the source goes down or if the service goes down, there's no persistence anywhere, right? So the messages are lost. But it works for simple use cases. Normally, you don't need this, but if you need to test something, it usually works. In complex delivery, oh, by the way, I should also mention that this is one-to-one case, right? You can only have one source and one service. If you need to have multiple services, you can't do it using simple delivery. In complex case, you have the notion of channels and subscriptions. So here, what you can do is that you can connect a source to multiple services using a channel in the middle, and each service can connect to the channel using subscriptions. So this allows one-to-many use cases, and these channels can be in-memory channel, but they can be persistent channels as well, like Kafka or Google Cloud pops up, so it gives you some kind of persistence. So this works for a lot of use cases as well if you need to do one-to-many. Now, you can also reply to messages. So in this case, for example, you have source sending a message to a few services, and then service 2, when it receives a message, it replies back with a message. And then this reply can go to other channels and other services as well. So this allows you to do a little bit more complicated things where you have a lot of events coming in, and some services, process messages and they add something to it, and then they pass it on to other services to process more, right? But at this point, things are getting more complicated because you have multiple channels and you have multiple subscriptions, and you need to connect them one by one correctly, and it gets quite complicated. So that's why we have the broker and trigger delivery. In this model, what you have is that you have your source talking to a broker, and broker lives in the namespace of your services, right? And it's kind of like the event mesh of your namespace, and it will receive the message. And then these services, they will register interest to the broker using triggers. In these triggers, these services say, I'm interested in this type of messages. So you are filtering on the type of messages. And also the services, they can reply to messages. So for example, in this case, service 1 and service 2, they're interested only in this kind of messages, so they will receive that message. But then service 2 will reply back, and then this message type will go back to broker, but then only service 3 filters on this type of message, so only that one will receive this message. So you can see that this previous use case that we did with complex delivery, with all the subscriptions and channels, you can do the exact same thing using broker and trigger delivery, using the right filters. So that's why it's much easier to deal with. So this is Knative, the way it delivers messages. In terms of event sources, Knative eventing allows a lot of different event sources. So you can listen messages from Kafka, from AWS, from Google Cloud pops up, from Google Cloud Storage events, things like that. I mean, this is not the full list. The full list is down here. But there's a lot of different kinds of event sources that you can listen, and you can also write your own event sources. So if you have something custom that you want to listen, you can write your event source, and Knative can pull that in using your event source and pass it on to your brokers. And all these events, as they come into your system, into your Knative cluster, they're all different kinds of events, right? So the type of the events are all different, but eventually they will be converted into what's called cloud events. Cloud event, it's an open source event definition from CNCF. And it's basically a common format for eventing in the cloud. And these cloud events, they have actually 0.2 is not the latest version. The latest version is 1.0. So all these events will have common metadata like type and the source and ID and things like that. And the data field of the cloud event will have the actual payload. So the GitHub event, for example, it will be converted into cloud event, and the data of the cloud event will have the actual GitHub payload. So this is done, and then by the time the event gets to the broker and to your services, it's a cloud event. So you don't have to worry about different kinds of events. You can rely on the fact that it's a single format. All right, so I want to show you an example of this in a quick demo. So in this example, what I want to do is that I want to connect Google Cloud Storage events to a Knative service, and then I want to use Vision API in my Knative service. So the way this is going to work is that users can upload images to a Google Cloud Storage bucket. So any kind of image that you want to store, you can upload it here. Then you can set the Google Cloud Storage bucket to emit messages when something changes. So when the image is saved here, it will send a message to a Google Cloud pops up topic that you define. So this message will be sent here. Then we're going to use Knative eventing to read that message through Google Cloud pops up source, and then from there pass it to broker. And then from broker, we'll create a trigger, and then that trigger will send the message to a Knative service. And then in Knative service, I'm going to do a Vision API call. So I'm going to call Vision API, which is a machine learning API. And I want to extract the labels out of this image and see what this image is about, and using machine learning. And then we'll log that out. But the important thing here is that we have a cloud storage event, like save an image, that triggers a Knative service that does something useful using Knative eventing in the middle. So I just want to show you how to set this up. So let's go back to my tutorial. So I have examples of all of this, like how to set up hello world eventing and simple and complex delivery, but we want to look at, first I want to look at pops up messages. So now we are reading Google Cloud pops up messages. We're going to be reading them. So first thing that we need to install is something called, there's a project called Knative with GCP. So if you want to read Google Cloud events in Knative, you can install this Knative with GCP component on top of your Knative installation. And with that, you get some sources, ready-made sources, to listen for Google Cloud events. So I did that already. And then one of those sources is called Cloud Pops Up Source. So this listens for pops up source from Google Cloud. So I already set that up as well. But I show you how to set it up yourself here if you want to. And then once you have the Cloud Pops Up source reading the messages, it will pass it to your broker in your namespace. But to get the broker in your namespace, you need to label the namespace. So here, I am labeling my default namespace with Knative eventing injection equals enabled. So by doing that, my namespace will have the broker injected. And once I have the broker, I can check that it's there. And then I can create a trigger to listen for those messages. So let's actually check this out. So first I want to, let me get out of here. So first, let's make sure that my cloud pub sub source is there. So you can see that my pub sub source test is there. Then I want to look at the broker. Broker is there as well. So it's injected into my namespace. Let me go to the eventing and vision. Now, let me show you the code quickly. We don't need this anymore. So if we go to Vision API, now I have the code here. I don't want to show the code again, like the code itself, basically, when it receives an event, it does a call to Vision API. You can check it out yourself because we don't have that much time. But what I want to show you is the Knative service definition. So this is a Knative service. The name is Vision, and I set the minimum scale to 1. So in Knative, you can specify auto scaling, and in here I'm saying that I want to make sure that there's a service running at all time. There's a pod running at all times, so that's why I set it to 1. And this is the image of my service that I already push. So this is just a regular Knative service. Then I need to create a trigger. So I need to connect my service to the broker. And to create a trigger, basically we create a trigger, and then we define the subscriber. And then the subscriber is my Knative service. Now I should also define a filter here if I want to filter, right? If I want to listen only for certain messages, I can filter here, do a filter definition here. But here I didn't do it because I don't need it. I just said anytime there's a message in the broker, just send it to me, to my service. So that's what I do here. And to set this up, so first let's create our service. So I have a Knative service. And then if I do get Knative service, you can see that the service is there. And then let's apply the trigger. Now I connect my service to the broker. And if I do kubectl get trigger, you can see that the trigger vision is ready. It's listening for messages from the broker, and it's sending it to the subscriber, which is the vision service. Now, if you look at the pods, you can see that the vision service is a pod. And let's just take a look at the logs of this service. So if I do logs user container, you can see that the service is just waiting for something to happen. I think I can watch this log. Let's see. No watch. Is it single watch? No, I think it's follow. Sorry, it's follow. Okay, let's follow the logs. Now I want to trigger the event. So to trigger the event, we need to upload an image. So let's go to Google Cloud Console. And let me go to Cloud Storage. So I created my bucket in Cloud Storage. And then here there's a bucket called Knative bucket. And I'm going to upload an image here. I already have an image, so let's upload the same image. This is an image with a sunset and the beach and mountains. So hopefully when we can travel again, we can go to places like this. So let's upload this. So now we're uploading this. I will replace the existing object. So we are uploading this image to Google Cloud Storage. That will trigger a pop-up message. That message will get to Knative Eventing, and from there we'll get to broker, and then from there we'll get to our service, hopefully. And if everything worked, you can see that our service received the content. So this is the actual cloud event that it received, and it's base64 encoded in some. So the data itself is base64 encoded, and then from there I extract the URL, which is the beach.jpg, and then I call the Vision API, and then we say this picture is labeled sky, body of water, sea, nature code. So we kind of extracted those labels from the image using machine learning. So it kind of worked, which is great. Now to delete this, I'll just say kubectl delete, then point to my trigger, then point to my service. Then if you look at the pods, then everything pretty soon should be terminating and gone. All right. So that's Knative eventing. Hopefully that makes sense. And now I don't have that much time left, but I just want to briefly talk about Cloud Run. Martin already talked about what Cloud Run is, but basically you can think of Cloud Run in the context of Knative as the managed version of Knative on Google Cloud. So it does the same thing as Knative. It brings serverless to containers, but it does it in a much simpler way. And I'm gonna skip these slides, the usual use cases and things like that. I just want to show you a quick demo of Cloud Run so that you get an idea of how it's different from Cloud Run. So what I want to do is, let's say, let me go to, by the way, I have another tutorial called Cloud Run tutorial, again on GitHub, that I'm going to share at the end of the talk. But in here, I show how to deploy a public service, how to do a private service, how to do service-to-service authentication, and other use cases. But let's just look at the public service. So let's say we want to deploy the same container, but on Cloud Run. How can we do it? First, you need to create your service. We already created our service from before. Then you need to build your container. Before, we used Docker to build the container. But here, since I'm going to be deploying to Google Cloud, I'm going to use Cloud Build Submit to build using Cloud Build. Cloud Build, it's basically a way to build containers in the cloud and then save it to Google Container Registry, which is a private space for your containers for your project. So by doing this single gcloud command, I can build my container and save it to Google Container Registry. So I did that already. Then to deploy to Cloud Run, I again use a single command. I just say gcloud run deploy, give my service a name, in this case, hello world public, point to the image, platform is managed, fully managed version, and then allow unauthenticated means that I want this service to be available to everyone. So let's just do this. And then let me see if I have echo service name. Let's set this to service name hello world public, and then do this. Now, this is, if everything's set up, it's doing the same thing. It's creating a new revision like Knative, routing traffic to this revision, and then setting up IAM policies, so making it public. So all of this is done. The biggest difference is that I didn't create a Kubernetes cluster. I didn't install Knative. I didn't set anything up. Everything is managed for me. So I just said, okay, deploy this container, and then Google Cloud does it for me. And if we go to Google Cloud Console again, now here under Cloud Run, you can see I have a bunch of services, but one of the services is Hello World Public. So let's just check that one out. I get this default dashboard where I can see some metrics, but it's a service no one uses, so there's nothing to see right now. Under revisions, I can see all the different revisions on my service. You can see that this one is getting all the traffic, and I just deployed it now. I get a default URL by default, so I don't have to set up a domain myself. I click on it, and it's the same as before with Knative. It will say hello v1, but it just set up for me. And then we can check out the logs. It has integration with Stackdriver. Once it loads, you'll see that we can see the logs of our service. Everything that gets logged shows up here. And then if you look at the YAML, it's actually the YAML, it's a Knative service, right? So that under the covers is Knative, except it runs on Google's infrastructure. And then you can do many more things here. You can deploy a new revision from here. You can change the settings and all that kind of stuff. But unfortunately, I don't have time. I'm already out of time. But I just want to point out that Cloud Run is a good way of running Knative-like services on Google Cloud. All right. So I think, and then there's different use cases for Cloud Run. So pops up messages, cloud storage events, you can listen, cloud scheduler. I will encourage you to check out my tutorial if you're interested in use cases. I'm already out of time, but just to mention briefly, in Knative, there used to be a component called Knative Build. This was probably like 3 or 4 months ago, but it turned into something new called Tekton Pipelines, which is a separate project now. And you can install Tekton on any Kubernetes cluster, and it gives you a way of doing CI/CD style pipelines using some primitives like task and task run and pipeline and service accounts. And if you go to my Knative tutorial, I'll show you how to set this up as well. This is useful because if you're running Kubernetes yourself, you can basically go from source code to a container image using Tekton, and from there you can use Knative to deploy that to a Knative service. So you can have the full end-to-end setup using all these open source technologies. So that's why I want to bring it up. All right, so I think I'm out of time, but thanks for listening. As I mentioned, the deck is already on my speaker deck, and the Knative tutorial and Cloud Run tutorial is already on GitHub. Thanks for listening, and now I will stop sharing my screen and I'll check out if there's any questions.